Okay, so let's look at a more slightly more complicated example of an ionic compound. This time we're going to look at what happens when you have a cation that is a transition metal. Okay? So the thing about transition metals is a lot of them can take on more than one charge. So for example, iron, Fe, has a charge of, can have a charge of +2 or +3. As an example. There are two exceptions to this. There is silver, which always has a charge of +1, and zinc, which always has a charge of +2. But the rest of transition metals are going to pretty much vary as far as what kind of charge they have. Because of this, when we actually go and we name compounds that contain transition metals, we have to specify which particular transition metal that we have. Okay, so there's a couple things that we need to realize for this. Okay, in your reading, I talked about how for groups 1 through 3, the charge is equal to group number. Transition metals, like we just said, it's going to depend. And for groups 7 through 9, it's going to be the group number -8. Okay, that's going to be important as we move forward here and we actually start naming compounds that contain a transition metal. Okay, so ultimately what we have to do when we're naming a transition metal is we put the cation first, we put the anion second, and we have to include a Roman numeral. So I'm going to go over an example of that right now and how you do that. Okay, so for example, one that contains, I'll go over two here, okay, 8 and 10 both contain a transition metal, okay. Now, number 8, the nice thing about zinc, as I told you earlier, zinc always has the same charge, so we don't have to put a Roman numeral. Zinc always has a charge of +2. So in this case, I name it as I did before. You put your cation, your anion, and you add that IDE. Okay, so in this case, it's the same. Since I know zinc always has a +2, I don't need to specify that. I just write out zinc. And I'll start with zinc phosphorus, but it's not going to be zinc phosphorus because we have to change it to that ID ending, so it's going to be zinc phos 5. Okay, students sometimes get confused with phosphorus. You want to make sure that you don't say phosphoride, it's phosphide, and that just comes from doing practice. Copper, however, is a transition metal, and we don't know which charge it is. Copper can either have a +1 or +2 charge. So here's how we figure this out. Okay, first thing, if you want to start, you can say copper. We're not sure what the charge is yet, so we'll leave those parentheses blank for right now. And then the second part here, we have oxygen. Okay, this is another tricky one. Instead of oxygen, we have to change that ID ending, so we're going to call it copper oxide. Okay, now let's see if we can't sort out what the charge of copper is. Okay, I know that I have 2 coppers bound to an oxygen. Okay, now oxygen is in group 6. So that means if I take 6 minus 8, that gives me a charge of -2. Okay, so oxygen has a -2 charge and there's 2 coppers. I know that for ionic compounds, the overall charge has to be equal to 0. Okay, so if I wanted the overall charge of this to be 0, the charge of each copper has to be a +1. So this tells me that I'm dealing with copper 1 oxide. Okay, we're going to go over some examples of this in class to kind of clarify this. The second problem might be a little bit more confusing, and that's okay. But make sure that you write down any questions that you may have so we can address them in class tomorrow.